Okay, it's time to look at the sine rule in our section on trigonometry. We've reached that point. We've been looking at the right-angled results of Pythagoras, SOHCAHTOA, that sort of stuff, some bearings, angles of elevation, and then looked at as angles go around the circle, and looked at different quadrants and relating those angles back to the first quadrant, finding exact values, that sort of stuff. So we're moving into a field of non-right angle trigonometry now. But before we launch into that, we're just going to have a look at a relationship between this angle here, made by a straight line, and the positive direction of x, being the two arms that make this angle 40 degrees in this case, and the relationship between the gradient of this line, which we know to be y over x, and something else about y over x to do with this triangle here being a right angle triangle, that being 40 degrees, that being the opposite over adjacent, which we know to be tan. Can you undo that, please? It doesn't work so well. Opposite over adjacent. So tan of 40 is equal to opposite over adjacent, which is equal to rise over run, which equals the gradient of this line. So finding the gradient of this line, which is what the task is just a matter of finding what tan 40 is, which I put through my calculator earlier, got 0.839. So that's the gradient of that line. Okay, gradient of this line here, it's a negative slope. The angle is 115 degrees. And so finding the gradient of this line is just a matter of finding tan of that angle there, 115, which is minus 2.14. So more generally, if we're looking at this angle here, theta, made with positive x and the line, then the value of theta is the value of the gradient, sorry, is going to be tan theta, and there's that relationship there. Okay, some questions in exercise 11F for you to do, please, from the work requirements. I think that's just questions 1 and 2, starting on page 379. But before we get into that, we're going to look at the sine rule and develop it from scratch. Started off with ABC as just any old triangle. It's not right angled, and the labeling of triangles is important here. We use capital letters for the angles, for the vertices, ABC, and we use lowercase letters for the sides, and those lowercase letters are opposite the angles. So side A is opposite angle A, side C opposite angle C, side B opposite angle B. Now what we do is we just drop a little perpendicular down here. We're looking to develop this sine rule and come up with the result. Using right angle trigonometry. So mathematics is a series of building blocks, and we start with very basic concepts of numbers, and over time we've built up lots and lots of different branches of mathematics, but they've all been based on previous knowledge. Everything's been based on things that have been proved earlier. So this is the nice thing about it. We've already proved some right angle trigonometry results. Now we're going to use those to develop some non-right angle trigonometry results. So firstly, we'll just drop this perpendicular down from B in this case to AC. Makes it right angle. Means we've got two right angles here we can work with. Working with the right angle, working with this one here on the left, sine A. If we look at sine A is equal to opposite over hypotenuse, which is h over c. So making h the subject of that, we get c sine A, quite straightforward. Over here, same idea, sine c equals h over a. Make h the subject, a sine c. So h is equal to a sine c, but it's also equal to c sine a. So a sine c and c sine a must be equal to each other, which they are. If we fiddle around with that equation, we get a over sine a equals b over sine b, which equals c over sine c. What that means is that the ratio of any side to the sine of its opposite angle will be the same no matter which side you look at. So A over sine A is equal to this side here over sine of this angle here, so B over sine B. So that's a useful result to find unknowns in a triangle. I've just made a note here that that's the version you'd use for trying to find a side. If you're looking for an angle's unknown, then you would just reciprocate all these fractions to get sine A over A equals sine B over B equals sine C over C. Still the sine rule, but that's the version you'd use if it was an angle that you were looking for. Okay, so we did so this is just an example from the work requirements. In fact, it's 11G question 1B, which is not one of your questions. Didn't want to steal one from you. So we were given the information in black, 40, 72 with the two angles here, 2.5 is that side. Straight away I just use angle sum to find 68. Well, the task is to find, we've got 3 pieces of information, we want to find the other 3 bits of information for this triangle. Well, the first one straight away, 68 degrees there, because the angle sum of the triangle is 180. Once we have that, we can use the sine rule to find A and B. Let's start with A. Always start with what you're trying to find. A over sine 40, opposite A over the sine of its opposite angle equals B. No, don't you say B, because I don't know what that is. Equals 2.5 over sine 72, so you can see my working there. So therefore A equals 2.5 times sine 40 divided by sine 72. Put that through your calculator, it's 1.69. Similarly for B, B over sine 68 will equal, let's go back and use 2.5 over sine 72. So B is equal to 2.5 sine 68 over sine 72, which is 2.44. Exercise 11G is yours to do now from the work requirements. Question 1 ACE, question 2 and question 4. But before I let you go, I want to have a look at use of the sine rule, but in questions where the angle might be obtuse. Because we know, I'm just going to scroll down here so I can remind you of a result that we've come up with. We know that if we find an angle to be theta, we know that there's an angle over here, so it's the same y coordinate, of 180 minus theta that is equal to this one. So we know that sine theta is equal to sine 180 minus theta. So for instance, sine 30 is equal to sine 150 because they've got the same y coordinate, which is there. Sine 40 is equal to sine 180 minus 40, which is 140. Sine 85 is equal to sine 180 minus that, which is 95. It goes on. So using that, and looking at question 1b now, the information you're given in 1b is this that you see on the screen, 50 in here for angle B, 17 for side B, 21 for side C. Now, we know that because side C is greater than side B, angle C has to be greater than angle B. So angle C could be an obtuse angle. So we have to take that into account, which is quite painful. But we're going to go through the process, and you will do with when you get down to the work in 11H. But I'll show you the process here. We go through and let's find out what the angle C is. Always start with what we're trying to find. So sine C over 21 equals sine 50 over 17. Work it through. We get 71.1 degrees for C, which is fine. It could be 71.1 degrees, and if it were, then we would find A to be 58.9 degrees just using angle sum of a triangle. And if A were 58.9, we could find side A here. Sorry, that wasn't very clear. We could find side A by taking A and putting it over sine 58.9 and dividing by, making that equal to 17 over sine 50. So we get A is equal to 19. So there's a result. So the three results, assuming that C is an acute angle, are right there. But go right back, C, this angle here, could have been 108.9. You remember that for this value of C, there are two angles less than 180 that satisfy this. And one of them is 71.1, the other is 108.9. So we have to consider that 108.9 could be our value of C, and this could in fact be an obtuse angle. And if it is, A is now 21.1, and we're going to put 21.1 down here to find side A, 17 sine 21.1 over sine 50, which is 8. So they're the three results for C being obtuse, and these three are the results for C being acute. We have to take account of both in this situation. We'll do one more question. It's D. So let me do a D here from 11H, and in this case I'm going to put this information in a diagram. A is 42 degrees, A is 33, the side A, and C, so that's B, and this is C side, C is 25. Now in this case, angle C has to be less than angle A because side C is less than side A. So in finding out what C is, I go sine C over 25 is equal to sine 42 over 33. So sine C is equal to 25 sine 42 over 33. So C is equal to sine inverse 25 sine 42 over 33. So we go to the calculator, sine inverse, so we put that in here, trig, sine inverse button. I've forgotten what I'm calculating. 25 sine 42, 25 sine 42 divided by 25 sine 42 divided by 33. Divided by 33. We'll hit equals, and we get 30.5 degrees. So C is equal to 30.5 degrees. And it can't be 150 degrees because this would be much, much bigger. So it must be 30.5 in there. And therefore B has to equal 180 minus 42 minus 30.5, which is, give me a moment here, I can work this out, 180 minus 42 minus 30.5 is 107.5 degrees, and then we would just need to work out what side B is, but I'll leave that to you. Okay, over to you, exercise 11H on page 385. Have fun with that.